So with decimals, there are two ways that we can classify them if they're rational numbers. The other kinds, irrational numbers, is something you'll really learn about in eighth grade math. So if they're rational numbers, we can either call them terminating or we can call them repeating. And so that's what we're going to go ahead and fill in some information about today to have as notes. So if you have a decimal that is terminating, it means that it has a decimal form that ends or ends in zeros. So if it keeps going 0, 0, 0, 0, 0, 0, 0, 0, 0, that's still a terminating decimal. Okay, so to terminate, right, like the, Terminator from those old movies there, he wants to, end people. This is where things are ending. So the kind of facts or characteristics with terminating decimals there would be that uh, we don't have to write the end zeros, which we kind of already know that, and you notice your calculator wouldn't do it if you try to put one in there. So an example of a terminating decimal would be something like 0.12, because it stops, it doesn't go any further, or 3.456789. Even though it goes on with a bunch of numbers, as long as it stops, it's still a terminating decimal. Non-examples then would be kind of the opposite word we'll talk about next, which is repeating. So that would be if you saw the same thing going on forever, like 0.33333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333to show you that it keeps going on. Or let's see, we could do 6.12121212121212121212. And again, sometimes we'll put the ... to show it kind of keeps going like that. So terminating ones and repeating decimals are the opposite. Oops. So if I go ahead and fill in the repeating decimal, let's see, I want to put this in. It has a decimal form that repeats the same digit or groups, or let's say group of digits without end. So it's not just a bunch of numbers that go on forever. That's actually something different. The key here is it has to go on forever and be repeating there. And so then we kind of talked about that, use the bar notation to write it. Sometimes you'll see, like we did in the non-examples up here, where they have the ... but the preferred mathy way to do it is to use that bar notation, which is that little line. So in the examples here, I put two that had the bar notation, so you could see them. I know it's hard to kind of type that in, but we could also put other examples than what we saw up here, like say 8.123, kind of going like that. And also, repeating decimals don't have to start repeating right away. So it could go like 12.456, and then 7777777777777. As long as at the end it ends up repeating, it's a repeating decimal. So non-examples would be anything that terminates. So let's see, we'll make some different examples than we did, like 2.75, terminating decimal because it doesn't stop. Or again, we could have big ones like 10 point, 1, 2, 3, 4, 5, 6, 7, 8. As long as it stops and it doesn't go any further, it's not repeating there. And that's pretty much it. So if it stops, it has an end, it's terminating. If it does not, and it's always the same thing that's going again and again, it's repeating.